All right, this will be for the sine and cosine equations. So they're both basically the same except for the sine and cosine. All right, we have y equals a times the sine of an angle k times the quantity of x minus b plus c. Okay, I put this part in brackets to indicate that this part right here is the angle. Okay, and this is basically in factored form with the k factored out and the x by itself. There's no coefficient in front of the x. It won't always be written this way, as you will see in the examples, but sometimes you need to factor out that k, that constant term. Anyhow, let's see what each letter represents, and then we will define them. So the coefficient in front of the sine or cosine, the absolute value is the amplitude. Okay, and the b is considered the phase shift. Remember, when it's minus b, it shifts right. So minus b will shift it right, positive b will shift it left. 2 pi divided by k is the formula for the period, all right? K is the number that's going to be factored out in order to have no coefficient in front of the x. And finally, c is the midline, all right? Remember, plus c, and that determines how far up or down the function shifts. So as far as the amplitude is concerned, the definition is it is the vertical stretch or compress of the function. Okay, I'll show you on the diagram. But basically, the formula for the absolute value, the amplitude, it's going to be 1/2 times the height. Or you can say it's 1/2 of the maximum minus the minimum. Now, as far as b, the phase shift, that is the horizontal shift. All right, so that's the left-right shift. And finally, the period is going to be 1 cycle of the sine or cosine wave. Okay, it's basically the horizontal distance from the maximum to the maximum or the minimum to the minimum. Again, I'm going to show you on the graph. And finally, C, the midline. The definition for that, it is the horizontal line that passes exactly in between the maximum and the minimum. All right, so if the formula for the midline, it will be 1/2 the maximum plus the minimum. In other words, it's the average of the two. All right, so the midline is 1/2 max plus min, and the amplitude is 1/2 max minus min. All right, so let's look at the diagram. And I forgot to mention a horizontal stretch or compression changes the period. Okay, the amplitude is the vertical stretch, but if there's a horizontal stretch, it's going to change the period. So let's look at the graph or diagram. Okay, so right here we have the amplitude. Okay, recall that we said the amplitude is half of the height. All right, so that's half of the height. Notice the amplitude, it runs from the midline to the maximum, or it runs from the midline to the minimum. Okay, let's label the maximum and minimum. All right, so this point is the maximum, this point is the minimum. Notice that the midline runs exactly in between the maximum and the minimum. Okay, so this line right here is your midline. And finally, the period is the horizontal distance of 1 cycle of the sine wave or cosine wave, okay? So let's say for the period, let's say we start here at the midline, we go to the maximum, we come back down to the midline, we go to the minimum, and we go back up to the midline. That horizontal distance right there is called the period. All right, so this is from here to here. From this point here to this point here, that is your period. All right, it is literally one cycle of the sine wave. Does it always have to be measured from midline to midline? No, you can certainly measure it from max to max. Okay, if this sine wave kept going, the maximum would be about right here. Okay, so if you start at this maximum and then travel to the other maximum, that distance right there is going to be the period. Okay, you can also go minimum to minimum. If this sine wave kept going, the minimum would be about right here. Here is the other minimum, and the period would be the distance from minimum to minimum. All right, so the period is just one cycle of the sine or cosine wave. It's the horizontal distance. The amplitude is half the height, and the midline is the line exactly in between the maximum and the minimum. All right, for the examples we're about to do, there is no plus C. There is no vertical shift up or down. So if there's no plus C on the end, that means C is automatically 0. And the line that goes in between the max and min will just be on the x-axis. So you'll see that on the upcoming examples. All right, example 1, we want to find the amplitude, period, and phase shift. Okay, so the first thing I am going to do is write my sine equation underneath. All right, so this equation is in the form of y equals a times sine of, I like to use the brackets. Even though they didn't use the brackets, this whole thing right here is the angle. All right, so I want people to be clear that this is the angle. So the 2 is factored out, and that's going to be x minus pi over 3. Whoops, I'm sorry. All right, I'm still using the brackets, but that's going to be the sine of k times the quantity of x minus b. All right, so we said before the amplitude is going to be the absolute value of A. The period is 2 pi divided by K, and the phase shift is B. All right, so we have everything that we need here. Let's do the amplitude first. All right, the absolute value of A. We can see that A is -4. So the absolute value of A is going to be the absolute value of -4, which is just 4. All right, so that's our amplitude. Now for the period, we said the period is 2 pi over K, 2 pi divided by K. So that's going to equal 2 pi, and we need K. All right, K, we can see K is the number out front, factored out of the x minus b. So clearly this number 2 right here is the value for K. So since K equals 2, in the denominator I'm going to write 2, and of course the 2's cancel. 2 pi divided by 2 cancels, and the period is just pi. All right, so the 4 was your amplitude, and the 2 pi over K was your period. And finally, the phase shift is just B. So make sure you watch the plus minus signs. You see that negative B is negative pi over 3. All right, if negative B is negative pi over 3, and then of course if you just multiply both sides by -1, you just change the plus minus sign on both sides. So B is just pi over 3. All right, positive pi over 3. And that is your phase shift. All right, so this is just a plus sign here. So in order to get your phase shift, this has to be in factored form. In other words, the K has to be factored out with the X by itself. And you will just take whatever's in the parentheses once you factor it out. Once you factor out the K here, you take whatever's in the parentheses and change the plus minus sign. So negative pi over 3 in the parentheses means that the phase shift is positive pi over 3. Okay, in other words, if I put it in another way, that means the function shifts right by pi over 3 units. Remember, when we said it's minus, that means it shifts to the right horizontally. So the phase shift is positive pi over 3. All right, please try this equation here. See if you can find the amplitude, period, and phase shift. And notice that I put the equation right underneath so you can line up the letters. All right, please try it. All right, so right here, there is a negative sign in front of the cosine. When there is no coefficient, it is automatically a 1. All right, so the A is basically negative 1. The absolute value of A is going to be the absolute value of negative 1, which is just 1. All right, so that right there is your amplitude. Now for the K, same thing here. The X is by itself inside the parentheses. What is factored outside? Well, if there's no number there, it is automatically just a 1. Okay, so the value for K is just a 1. All right, so 2 pi over K is just going to be 2 pi over 1, which of course is just 2 pi. And that right there is your period. Finally, the value for B, like we said before, you have to change the sign. We can see right here that negative B is positive pi over 2. All right, see the formula has, the equation has it as negative B. Right here it's positive pi over 2. So, if negative B equals positive pi over 2, how would you find B, or positive B? You just change the plus minus sign on each side. If negative B is pi over 2, that means B is going to be negative pi over 2. All right, and that right there is your phase shift. All right, so like I said, if you just take what you have in the parentheses, see you have a positive pi over 2, and just change the plus minus sign, make it negative pi over 2. All right, so pretty simple. All right, last one, example 3. Before we get to the specifics on this one, see if you can factor a 2 out of this angle right here in parentheses and try to get the equation in this form. So the beginning of the equation doesn't change, but factor a 2 out of this part here, and then we'll compare. So we have y equals, and the value for A, 1/2 cosine, that doesn't change. All right, so that's going to be 1/2 cosine. And I'm going to use my brackets here. And I am going to this is the angle right here. I'm going to factor out a 2. All right, so 2x divided by 2 is just x. And 2 pi over 3 divided by 2 is just pi over 3. Close the parentheses, close the brackets. So if you distribute this 2 times x is 2x, And 2 times pi over 3 is 2 pi over 3. It is the same equation in a different form. I just factored out the k. Okay, so now from this point, see if you can do the amplitude, period, and phase shift. All right, amplitude is the absolute value of A. So that is just the absolute value of 1/2, which of course is just 1/2. All right, next up is, all right, for the period, 2 pi over k. And since we factored this, we can now see that the value for k is just 2. All right, so it's going to be 2 pi over 2, which of course is just pi. Finally, the phase shift, B. Let's see. We can see that negative B is positive pi over 3. So that means B is going to be negative pi over 3. Remember to change the plus minus sign. All right, so B is just negative pi over 3.